is Greg Vanilo from Virginia Tech, and I'd like to welcome you from Virginia and North Carolina for today's webinar, which is the 7th in our series of composting webinars. Today's speaker, it will be Craig Coker, but before I introduce our speaker, I'd like to let those who've participating today and have participated in the past that we are currently seeking credit hours from the U.S. Composting Council for the Certified Compost Operations Manager Program, so that once those are approved, anyone who's taken our previous or sat in our previous webinars or our future webinars will be able to get credit. And in many cases, those are reciprocal between states and the U.S. Composting Council. So with that, I'd like to start today's presentation, which will be made by Craig Coker. Craig's been a frequent presenter for us. He has over 35 years of experience in the planning, permitting, design, construction, and operation of composting facilities. And today he'll be speaking on odor management. So Craig, it's your show.
Thank you, Greg, and thank you, Mark, and welcome to everybody to the webinar. I'd like to thank the U.S. Composting Council and their Compost Operator Training course for providing some of the information that's used in this presentation and others that we teach here at the Maryland, Virginia Better Compost School. We're going to start, we have some poll questions built into the presentation, and they're in part to find out you know, how, if quite honestly, if you're paying attention, the first poll question though is to drive home an important point about odor management. Okay, how many of you like the smell of a chemical called hepta-2-one, which is the chemical that creates the smell of blue cheese dressing? Raise your hands.
Okay, I've launched that poll and we're getting some responses now. We'll just take another.
See everybody's hand up. Very evenly distributed. We have 31% of the respondents that love that smell, 38% hate that smell, and 38% are indifferent and are more concerned with when lunch is. Well, that's interesting because what that tells us is that odors are unique to individuals. The human olfactory system, which you see in this illustration, contains olfactory neurons at the upper part of your nose, in your sinuses, and those neurons transfer a sensation of an odor to an electrical signal to the brain. Human beings have the ability to detect odors through what are called scent receptors that are tied to these neurons, and we have about 400 different types of scent receptors in our olfactory system. And every one of us, because we all have different DNA, we all have different olfactory neurons and different scent receptors, which is exactly why some of you like the smell of blue cheese dressing, some of you hate the smell, and some of you are indifferent. This is true of all odors. Some people, now there are some odors that the vast majority of us would find truly objectionable. There are some, for example, I've worked at leaf composting operations where citizens have complained about the odor of decomposing leaves. But that's the nature of the odor management problem we have with composting. It is the #1 issue that will shut down a composting facility, without a doubt. Well, what are odors? They are a mix of several different volatile compounds. Now, volatile here means a gas has been emitted and that gas is moving through the atmosphere to the receptor. We'll talk about that in a minute. That's called the odor chain. Odors are inherent to the decomposition of the organic chemical bonds that make up the materials that we try to compost. And so they are going to occur. Composting can never be odor-free. It's physically impossible. Odors are transient in both time and space. Their chemical composition can be modified by external factors. They are subjectively offensive, and it is the subjective nature of odors that makes regulating them so incredibly difficult. But when all that's said and done, it is a manageable problem. Let's look a little bit at the concept of odor science, which is a very well-developed science in our country. Different kinds of terms that you'll come across in the field of odor science. Odor concentration, much like an air pollutant, it's usually a mass per unit volume. Odor intensity, a subjective scale that relates to how intense the odor is. Persistence, a little bit of a different concept than intensity. Persistence is how an odor, certain odors can have very long duration. I'm sure many of you have visited various waste management facilities, and while the odors weren't strong, you get back in your car and 3 hours later, you're still noticing that odor in your clothes. That's a persistent odor. Ammonia, on the other hand, you detect it, but it doesn't stick around a long period of time. Ammonia is not a persistent odor. Character, obviously a subjective concept of, is it pleasant? Is it okay? Is it not so okay? Is it truly egregious? And hedonic tone, another measure of the unpleasantness of an odor. Now, in terms of concentrations of odors, we use terms called the odor detection threshold and the recognition threshold. The odor detection threshold, or the perception threshold, numerically is about 1 odor unit per cubic meter of air. It is the minimum concentration in which you can detect an odor. That's that classic whiff of something you get and you go, what's that? The recognition threshold is the concentration at which you can identify what that odor is, and it's usually 2 to 10 times the odor detection threshold. Dilution to threshold we'll get into in a minute. That's another term you'll see in odor management. Odor units and odor dilution units are also numerical values that you will see. The potential for something to become an odor depends on the volatility of that chemical. And volatility is the ability of the odor to leave the processing environment as a gas. As we mentioned a minute ago, the recognition threshold is the ability for that odor to produce some sort of response, positive, neutral, or negative. And it varies from person to person, as I said earlier, because the DNA that makes up our odor neurons in our sinuses differ from person to person. Odor concentrations can be correlated with a concept called odor index, which is the logarithmic relationship between the concentration and an index value. As you see here in the example calculation, if an odor is 500 odor units, the odor index works out to be 27.0. And we'll show you some examples of that here in a minute. But the concept of volatility goes back to the molecular weight of the chemical. This table shows you a list of very common odorous compounds in composting, particularly biosolids composting, and the molecular weight of each compound and the boiling point. Notice that as the molecular weight goes up, so too does the boiling point. It's simple physics. Also note the detection threshold. In parts per million, ppmv is short for part per million volume, which is a way of expressing a gas concentration in an atmospheric environment. Keep in mind, 1 part per million is the equivalent of 1 inch in 15.8 miles. 1 inch in 15.8 miles is 1 part per million. And some of these numbers are much lower than 1. So the detection threshold of many of these odors is so low that virtually everybody can detect them. Odor indices, as I mentioned earlier, is a logarithmic relationship between concentration and a numerical index value. And you see some examples here. This is from the world of wastewater treatment and sludge management. For the most part, some of these are obviously very strong odors, and you can see the various odor indices in the left column. The third column from the left are the odor units or the dilutions to threshold. And then on the right column is the list of examples of where they come from. Now, dilution to threshold is a physical process in the atmosphere, downstream of the source. Those of us who have been in the environmental industry for a long time remember in the early days there was a phrase called dilution is the solution to pollution. And that phrase fell out of favor because it implies that you can merely make the problem go away by diluting it. But in the case of odors, that's exactly what you have to do. You have to dilute the odor to get it down below the detection threshold or below the recognition threshold for sure, and ideally below the detection threshold. So dilution to threshold is a mathematical concept, and there are ways of measuring it. The American Society of Testing and Materials has a national standard for measuring odors with an odor panel. And an odor panel is made up of eight or more people who test with their noses various concentrations of a sample of material or an odorous material. And the dilution to threshold is the number of dilutions of fresh air that are required to dilute that sample until half the panel could no longer detect. So if you need 3 cubic feet of dilution air to dilute 1 cubic feet of odorous air, then dilution to threshold equals 4. Most states regulate odors on the basis of a nuisance standard, which is challenging in and of itself. There has been a lot of discussion about regulating odors based on dilution to threshold numerical values because those are measurable values. There are some challenges in how you measure those values, though, which we'll talk about. So every composting and anaerobic digestion facility should have an odor management plan. Now, this plan will discuss the sources of odors and the mitigation options. It will discuss how odors are going to be monitored, and importantly, how are complaints going to be handled. Every facility should have an odor management plan of some sort because there will be events that occur that create odors. The picture in the lower right is the now closed Heartland Biogas Digestion Facility in Weld County, Colorado, which was handling manure from regional dairies in the area as well as food waste from metropolitan Denver. And clearly, when it's discharging raw manure out through a pipe, as you see in that photograph, reasonably certain that there are some odors around that facility. So another term for an odor management plan is an odor impact minimization plan, and it has these elements: your monitoring protocol, an understanding of the meteorological conditions of the site, how the complaints are going to be handled, and how design and operating considerations are managed. As I mentioned earlier, we have this concept of the odor chain. We have odors that are formed in composting and digestion. They are transported off-site by meteorological conditions, and the receptor, the human nose, perceives them and reacts to them. So in order to control odors, you have to break this chain somehow. Well, let's start with odor formation. Odors come from a number of sources in our biological manufacturing facility, which is the real concept behind composting. We have feedstocks that come in from off-site. Those feedstocks can be odorous. We have various preparation and mixing steps that are taken that can create odors. Active composting, of course, is going to create odors because of the decomposition of carbon, hydrogen, oxygen, nitrogen molecules in the pile. Curing can have odors, screening can have odors, and water management as well as dust control can have odors. So all those are different sources in a facility. This is some data from a project in Oregon a few years ago where they were having odor problems. They sent a team of air quality engineers there who did some very detailed air sampling and analysis, and were able to find that the percentage of odors were coming from these different sources. Now, obviously, composting and curing would be expected, and they were surprised by the fact that 30% of the odors were coming from the biofilter, and it was because the biofilter had been allowed to dry out and was short-circuiting, so odors were not getting treated by the filtration system. We'll talk about biofiltration a little bit more here in a minute. This is the Cedar Grove composting facility in Everett, Washington, 160,000 ton per year facility that uses the Gore microfabric aerated static pile composting technology. They have had a large number of problems with odors over the years and have spent many millions of dollars in managing it. In their analysis, they found 14 different locations that were producing odors. So it wasn't just at the front end of the facility. This is the white building on the left. Upper left is the receiving building for solid waste that come in, food waste that come in from the Seattle area, and grinding. Then the first pink oval is their active phase 1 composting. The second one to the right of that is phase 2 composting. The third one is curing. And then beyond that third pink oval is their screening and product storage area. Notice at the bottom of the photograph, they have aerated stormwater lagoon. And those aerated lagoons can be a source of odors. So 14 different sources at one particular facility that have to be managed in one way or another. What kinds of chemicals do we see in the odor profile of most composting facilities? We see the worst odors from compounds that contain sulfur. And these would include chemicals called mercaptans, hydrogen sulfide, which many of you are familiar with, other forms of organic sulfides, some nitrogen-bearing compounds, amines and ammonia, urea, and those types of compounds have strong odors, and volatile fatty acids have strong odors. We find there are several biological sources of sulfur in composting. We have amino acids in proteins that contain sulfur. If those proteins decompose aerobically in a compost pile, you will get mercaptans. If they decompose anaerobically in an anaerobic digester, you will get hydrogen sulfide. Hydrogen sulfide, not being water soluble, does have a tendency to volatilize, and it tends to be more prevalent when the pH of the material drops below 7. In some states, we see a regulation called total reduced sulfur compounds that are regulated. And this is the numerical sum of the concentrations of hydrogen sulfide, methyl mercaptan, dimethyl sulfide, and dimethyl disulfide. And the last two, DMS and DMDS, are organic sulfides. We see them a lot in sludge composting. The first facility I worked at in the 1970s and 80s was a sludge composting facility in the Washington, D.C. area. And we had a 4-stage chemical scrubber to try to get the DMS and the DMDS out of the exhaust gas. Biological sources of nitrogen are odorous. Ammonia is the first decay result of the organic nitrogen in nitrogenous materials like food waste or animal manures or grass clippings. Ammonia is fairly soluble in water, and it stays in the ammonium form if the pH stays below 7. As pH begins to rise, ammonium shifts to the ammonia form, and then it volatilizes off as a gas. And as temperatures rise, that transition, once pH is above 7, happens with increasing speed. This is why in some composting facilities, particularly those handling biosolids, there's a strong ammonia odor in the first couple of days of composting. Volatile organic compounds are the predominant air pollutant in organics recycling, and it could easily be argued that all odorous compounds are VOCs. Not all VOCs are not necessarily odorous, but VOCs are regulated, particularly in California, where they contribute to the formation of low-level atmospheric ozone in the photochemical smog. So in areas where there is an ozone non-attainment, where the area does not meet national ambient air quality standards for ozone, usually some form of emission offset is going to be needed with regard to a new facility. Feedstock receipts are a big issue in composting because feedstocks are frequently odorous when they are delivered. And so if you run a facility or you have people in your state that operate facilities, they should recognize that some of these feedstocks may not be worth the tip fee because of the potential odor problems they create. So all feedstocks need to be managed with regard to their odor potential. They need to understand their sources, their type, the potential for negative odors, and have laboratory data before they agree to accept it that understands the moisture content, the density, particle size, the degradability, the carbon-nitrogen ratio, all the basic compostability parameters that you need to run a well-defined and well-operated facility, well-defined recipe at a well-operated facility. Unloading protocols are important. If you're taking in liquids, you certainly want to absorb them quickly with something that's dry. You want to mix your bulking agent in upon receipt and get that material mixed and into your composting system, ideally within an hour, certainly within 2 or 3 hours. Some of the greatest problems I've seen at facilities are where the truck comes in at 4:58, unloads on the pad, it hits 5 o'clock and the operators walk away. And it sits there all night and come in the morning and you have an odor problem. Now, timing is important. This is a photograph provided by Kerry Oceans of the USCC of a truck unloading dissolved air flotation sludge at a farm-based composting operation. The minute that kind of liquid goes into a truck, it's still decomposing, but it's now decomposing anaerobically. So generally speaking, you would not want to receive this material if it's been sitting in that truck for more than 2 or 3 hours. And that doesn't necessarily restrict it to distance. Consider the traffic in metropolitan areas, particularly crowded metropolitan areas like New York, Los Angeles, and Washington. Sometimes with bad traffic, it can take 2 hours to get across the city. So when these materials come out of these trucks, if they've been in there for a while, they are going to have an odor profile with them. Those of you who have seen food waste composting operations have seen this happen. Food waste tends to liquefy in the transport truck, and when you undog that back gate and open it up, there usually is a rush of free liquid of some form that is often very odorous. And so it's important that operators unload these kinds of wet, sloppy materials on a bed of dry amendment. You see here on the left a bed of mulch, on the right a bed of compost, and that helps soak up the liquids and helps minimize the formation of bad odors. Obviously, bulking agent is important because you have to maintain aerobic conditions. So it's important that when you get these materials in, that they are quickly amended with good bulking agent that gives you good porosity. So your net bulk density of the final mix is somewhere in the 850 to 900 pound per cubic yard range. You want both small and large particles in your support matrix in order to ensure good free airspace. And it can be by weight as much as 50% of your total blend. And in some cases where you have, the types of woody materials that have high lignin contents, it can climb up above 50%. So these are your basic guidelines for what you're trying to do with your mix design. You want your CN ratio in the 25:1 to 40:1 range, moisture in the 50 to 60% range, pH 5.8 to 7.5, and you want to make sure you've got good particle size distribution. So operators should always test for free airspace. And there's a number of different methods that have been taught in various compost schools about how to do a free airspace test. You always want to mix your fresh ingredients with bulking agents within hours of delivery, as I said before. Usually what you want to do is put your dry material down, add your wet material on top. If you're going to turn with a bucket loader, which is a very inefficient way of mixing, you really need to go through it 4 or 5 times to get it really mixed correctly. If you have a windrow turner or the facility has a windrow turner, they are very efficient at mixing materials together with a couple of passes, and many facilities will now have a standalone dedicated mixing system. One of my facilities I owned, I used an old agricultural feed mixer, and it worked just fine. So odors are going to be released most in the first 14 days of composting, because that's when our most active decomposition is going on. You have higher biological activity and higher oxygen demand. So there's a need for those facilities that have aerated static pile. You have to make sure you have adequate air supply to meet that high demand in the first couple of weeks. For those facilities turning windrows, you have to turn fairly frequently in that first 14 days, but you've got to be careful not to turn at the wrong time. Here in the mid-Atlantic, in the fall, between the early fall and late spring, sometimes you'll get a very stagnant air pattern that sets up early in the morning. And in some cases, you can see it as a bank of fog that drains in river valleys and stream valleys. That stagnant air is going to stay stagnant until the sun comes up and heats the atmosphere. And if you turn a windrow at 9 o'clock in the morning when the air is very quiet and still, you are going to create odors that are going to hang close to the ground, and they could create problems. And obviously, if the wind is blowing in the direction of a sensitive receptor, it's never a good time to turn. Okay, now we have another poll question. This one is a multiple choice question. Which of the following could be a source of odors in composting? Feedstocks that are too wet, trucks delivering feedstocks that have been on the truck a long time, Christmas trees and wreaths, seeing we're at that time of year, leaves, or all of the above.
Yeah, I've launched that poll now and getting some results in. We'll just take another 10 seconds or so.
Well, 82% of the responders said all of the above, and that is exactly correct. Christmas trees will contribute to odors, even though it's usually a nice odor. Okay. All right. Lack of oxygen is our main reason for odors in a compost pile. Terpenes, which is the chemical that is responsible for the smell of fresh cut wood, and ammonia are formed even though there is oxygen in the pile. Odors will normally form in anaerobic pockets or zones. And all compost piles have anaerobic corners or pockets. So by aerating and turning, you will release those odors, that are trapped in the pile. This is an odor depletion curve from a turned compost pile. So the minute you turn the pile, the oxygen will climb back up towards the natural maximum, which is 20.6% of oxygen in free air. But it will also drop off very quickly because the microbes have been stimulated by this introduction of fresh air. Biological oxygen demand shoots up, and that oxygen depletion curve is on the order of 20 or 30 minutes. So you can't turn a pile every 20 or 30 minutes, at least not economically. So you have to have good free airspace to make sure that the pile stays aerobic in between turns. Stormwater is becoming an increasingly important matter in composting facilities. As you saw in the picture of Cedar Grove in Washington State, they use aerators in their storm pond. You see an example of an aeration system here. Does this reduce odors or add odors? It actually does both. It reduces odors by increasing the oxygen content of the water in the pond, which helps degrade the odorous materials, but it also volatilizes odors by throwing a lot of stuff up in the air. Other sources you'll find on your sites: screening. Even though you're normally screening material that is you should be screening only material that is biologically stable and ideally fully mature, you can still get some odors from screening by virtue of the fact that dust particles can have odorous molecules affixed to them. Sites are a big source of odors, particularly from ponding and materials that get out of, or what we call fugitive materials that get escaped from a pile. Curing piles, as we talked about, stormwater ponds. So here you see a facility where water has been allowed to pond up on the uphill side of the pile. Well, that pond, that little puddle is going to have organic materials in it that are going to decompose anaerobically. The bottom of that pile is saturated to the point where oxygen cannot get in, and so it too is going to go anaerobic, and those are going to be sources of odors at a site. So turning procedures that operators should have for turn windrow operations are shown here, and they need to have in their operations plans and in their operating procedures well thought out and well managed processes for turning windrows regularly as needed, but with one eye on the weather and on wind direction. For aerated static piles, the design has to have enough air to meet the initial oxygen demand of primary decomposition. And then we're beginning to learn that as aerated static piles dry out much more than turned piles. So there is often a need to break the pile down, moisten it, and rebuild the pile to make sure everything degrades properly. So some methods of controlling odors are what are called biocovers. Now, biocovers are, as you see here, different approaches, a couple inches of compost, screened compost, a little bit thicker layer of unscreened, or just a layer of woody overs, as you see in the lower photograph. You have to be careful because if you look at the upper photograph, the operator has his loader bucket extending over the pile too far. And so as he's shaking the compost out to cover the pile, he is covering the bottom of the windrow. Remember, windrows breathe. Hot air comes up from the middle, is replaced by cool air coming in from the side. In the upper photograph, there's a real risk, particularly if you're using screened compost, that you will choke off that replacement air supply by making it impossible for the windrow to breathe. Research by San Diego State University and others in California have shown significant reduction of VOC emissions with these compost caps or biocovers. You see in this graph here, the blue line is the VOC emissions from a typical compost windrow. And as you can see, maximum VOC emissions, AKA odors, in days 5 through 10, with a compost cover over it, virtually none. So we have seen, the data shows as much as a 90 to 95% reduction in VOC emissions with compost covers. We see a growing number of facilities using various types of permeable covers, selectively permeable membranes that are of various textures. The one on the upper right is just a simple polyethylene fleece material, very effective, and widely used. The lower two photographs are the Gore microporous fabric, the same fabric that they make windbreakers from. These have good potential for reducing odors. We see some facilities using surface reactants that are claimed to be odor neutralizing chemicals. But if you think about the chemical nature of odors and the fact that it's not just one chemical, but rather several chemicals that are combined and they have different effects and different intensities and different hedonic tones, it's a little bit hard to understand how one chemical spray can knock all those odors out. And I tend to be a little skeptical about some of these misting or spray systems. Now, you can certainly treat the air if you have the ability of capturing it with a biofiltration system. Now, biofilters are really nothing more than very large compost piles, and you can get a very effective reduction in odors from with the use of a biofilter. You see several pictures here. What happens in a biofilter is that the organic compounds that are in the exhaust air are absorbed into the water layer around each particle in the biofilter, which is why biofilters need to be kept moist. The microbes live in that biofilm and they degrade the pollutants in the exhaust air, just like they degrade the components in a compost pile. The media has to have the ability to pass the exhaust gases through the media, but not so quickly that the microbes don't have time to do their job. So we design these for anywhere from a 45 to 60 second gas retention time. during which time the microbes digest, degrade, and oxidize the compounds. This is a facility I designed in North Carolina for biosolids composting. Again, obviously all in a building. And there is a growing trend in our industry to move composting facilities under roof. In this example, we have exhaust piping in the upper side wall of the building, pulling air out of the building through the distribution blowers and into the distribution piping. And the distribution piping lies underneath the biofilter bed, which is about 4 feet thick. This is a schematic of a biofilter. You see here the air distribution piping is lying on a slope so that the water that condenses out will drain. It has a plenum made of gravel that allows for even distribution of the exhaust air up into the biofilter media. Airflow goes through the media. You have the biofilm and the around each particle, and that allows for the degradation of the material. Very effective, very inexpensive to build. And when the biofilter media ultimately gets exhausted, you clean it out, you compost the biofilter media and replace it with fresh media. You have to do that about every 3 to 5 years. That's sources and mitigation options. Now let's talk about monitoring. How is a compost facility going to know if it has a problem? Well, for that, we need to understand the transport mechanism that links odor sources with odor receptors. There are a number of different ways for odors and air pollutants to be removed from atmospheric conditions. They are diluted by air, particulates will settle out, the rain will wash odors out of the air. Every one of us has walked outside after a rainstorm and smelled what the air smells noticeably different. There are photochemical reactions from sunlight that affect odors, and you can have absorption by plants and soils. And absorption by plants is one of the most important reasons why you need a very healthy and vigorous vegetative buffer of both lower and upper canopy around all processings in a composting facility, so those plant leaves intercept the particulate matter and help keep the odors from leaving the site. Now, dilution is not just the wind blowing. There is a vertical movement to the atmosphere created by solar heating. So the atmosphere moves both horizontally by virtue of wind and vertically by virtue of temperature. And there are times in which everybody's probably heard the term temperature inversion. That's a unique meteorological phenomenon that can trap odors down near the surface. So you have to understand the micrometeorology of every site that you work at. Now, every facility should have the ability to monitor atmospheric conditions in order to be sure they understand how things are, how the weather is potentially affecting operations. These meteorological stations, I get mine from a company called Forestry Supplies, and they run less than $1,000. And they measure wind speed and wind direction, rainfall. The more advanced models monitor other meteorological phenomena. And all that is recorded on a computer. So you have the ability at your desk, or the operator has the ability at his or her desk, to look at the data, and the phone rings, and Mrs. Smith, who lives west of the facility, says, "I can smell your facility," and you look at the data and realize that the wind is coming from the west and blowing to the east, so it's not really likely Mrs. Smith smelled your facility. If you don't have that data, you don't have the ability to make that argument. If you're doing siting for a facility or planning for a facility, it's a good idea to understand the 5-year history of the wind speed and direction. And the way you do that is with what is called a wind rose. And you see one here for a facility near me here in Virginia. This shows the direction that the wind blows, either blows from or blows toward. In this case, it's blowing toward, and the different colored bands represent wind speed. Now, this kind of meteorological data is normally measured at a local airport. So, I live in the mountains of Virginia, so there are topographic issues that maybe where the airport data may not be exactly accurate for a particular site due to terrain. But if you live in a flatter area and you're within 20 or 30 miles of an airport, that data is probably pretty representative of the site that you're thinking about. Monitoring protocols have to be in place as part of the odor management plan. You need a daily routine evaluation. It's very important that whoever's doing the human olfactory detection not be somebody who works at the site all day, because if you work in composting all day long, you become inured to those smells and those odors, and it becomes very difficult for you to detect anything. If there are odors detected, then it's obvious, the steps to be followed are shown here. Investigate sources, alert management, evaluate off-site impacts, develop remedies, and document everything. Make sure everything you decide to do or that the operators decide to do is very thoroughly documented. This is a composting facility in Prior Lake, Minnesota, outside of Minneapolis. There is an industrial hygienist who works for the owner, and every morning at 5:30, that young man drives around to these different monitoring stations with what's called a nasal ranger. It's a field olfactometer in which he can calibrate dilutions to threshold at each one of these monitoring stations. And that way they have a database built up over time of exactly where and when odors are occurring, which allows them to respond in the event of an odor complaint. But this is the kind of regional or area type odor management system. And some of these distances, and it's a little hard to see on the slide, but for example, from the center of the facility to the monitoring station number 9 on the right is 4,500 feet. So some of these are can be pretty far away. Poll question number 3. Why is the floor of a biofilter sloped? Is it because it's cheaper to build? Because there's more filter media at the far end of the slope? Or for drainage of condensed water?
Okay, I've got results coming in. We'll just take another 10 seconds.
Okay, the last part of an odor management plan is how are you going to handle complaints? This is a challenge because whoever's calling to complain is probably upset. And upset people don't always act rationally. But it's important that operators and managers of facilities treat everybody with respect and stay very proactive about everything, keeping the community informed, communicate the odor management plan. Let people understand that you understand that they have a concern and it's a valid concern. What you see in this slide is called an odor wheel. And it's an attempt by odor scientists to correlate the different chemicals that create odors to the materials that those chemicals are derived from, and to categorize them in different areas. It's very hard to get upset people to say exactly what an odor smells like, but it's important to try to get them to say, okay, well, no, it doesn't smell like that. It smells like this. And these odor wheels are often used for helping people understand a little bit more about the nature of what they're smelling. And that helps the operator understand what the source might be. Complaint protocols require that you have a fairly standard form. The Texas Commission of Environmental Quality has a very interesting form called FIDO, which is short for frequency, intensity, duration, and offensiveness. And those forms are used by Texas composters to track any odor complaints. So you have time, you have location, you have weather characteristics. Ideally, you try to verify, and this is where regulators have such a hard time with odors. At the facility in Prior Lake, Minnesota, I was showing you earlier, there were complaints registered by people who noticed an odor as they were walking out the door to get in their car. And thanks to the world of cell phones, you can make a call and file a complaint with a regulator before you start your engine. And yet the regulator then has to travel from his or her office to the site and verify that odor is still occurring. Well, sometimes they're so transient that that's very, very hard to do. But nonetheless, it's important that operators of compost facilities and digestion facilities work with neighbors to try to verify problems that are occurring when they occur. And as I said before, documenting everything. So odor management plans make operators responsible to the community. They allow for the planning of the consequence of odors before problems emerge. It provides a mechanism for response and for communication, and provides a process. So all facilities should have an odor management plan that understands the sources, the mitigation options, the monitoring procedures, and the complaint protocols. And with that, we'll see if anybody has questions.
So we have plenty of time. Craig, I want to thank you for staying right within our time frame, especially as we're getting near the holidays. It seems like people are more anxious to move on. So so let's see. We've got a question from Bill Miller. How significantly would you say plastic film in feedstocks contributes to odor problems?
Plastic film, low density polyethylene plastic film. Well, in and of itself is not odorous, but it probably does have a negative effect on a pile's free airspace, because sometimes after that low density polyethylene film has been exposed to ultraviolet light and sunlight, it gets brittle and starts breaking down, and those small pieces can be a problem. But is it a significant contributor? I would think not.
Okay, so is people still thinking about some questions they may have? I'll just remind people, for those who may have tuned in a little late, or just to repeat, who may have not picked it up the first time, we are currently applying for credits, professional development hours from the U.S. Composting Council Certified Compost Operators Managing Program. And so the people who are participating in this webinar, and those who are have participated in previous ones for which we have records, or in future webinars, will be able to get credit through the U.S. Composting Council program. Let's see, any other, let's see, some chat. Okay, so there's a question that came through on chat. And this seems to be a question, maybe it's meant for Carl. It does go to all panelists, but to Craig. Did Cedar Grove abandon the practice of spraying eucalyptus scent to mask odors?
I don't know the answer to that, Carl. Sorry. I'll see if I can find out and get back to you.
All right. Another question from Marshall Hall. Seafood items seem to be a particular challenge. Any info on that smell profile and creative ways to mitigate?
Yeah, seafood is particularly odorous material. And so if it's not a forced aeration static pile composting approach, then I would recommend a passively aerated static pile system. And in a passively aerated system, you take a PVC pipe, slotted or perforated PVC pipe, and you turn the pipe transverse to the long axis of the pile so that the ends of the pipe are out in the open air. And then you build your pile on top of it, but you do not turn it. You would cover it with a bio cover of compost or unscreened compost, preferably. But the air then comes in through the open ends of the PVC and migrates up through the pile. And I've used that for seafood waste when I was composting down in North Carolina. Works very well. You can't, obviously you don't turn the pile, but as long as you have good structural porosity, good free airspace, having that passive air infiltrate up through the pile, through the PVC piping, is very helpful for seafood.
Another question, Craig. This one is on separation distances. Do you recommend a compost site have a minimum distance from neighbors? And I'll even add a little bit more to that. What do various regulatory agencies say about this?
Most regulations in states I work in have anywhere from a 200 to 500 foot setback from the residence not owned or occupied by the permit applicant. That's a very short distance, quite honestly. I worked on an odor problem at a facility in San Antonio, Texas, which was right next to Interstate Highway. And it turned out that the velocity of the vehicles passing by the site created atmospheric turbulence, sort of a micro turbulence, right above the interstate. And it caught the odors, kicked them up in the atmosphere, and they came down 2.5 miles away. Now, that's a unique site because it was right next to an interstate. But that's where you have to understand the micrometeorology of things, and not only the wind direction, but things like, things that could influence odor dispersion, like a highway. So I would say, generally, as a rule of thumb, I tell my clients, you want to be at least 1/4 mile between your processing areas and any sensitive receptor, which I define as either a residential home or anywhere the public gathers, church, park, school, hospital, etc.
Greg, before you go any further, let me jump in. I'm going to put the link to your survey inside chat, and if folks would, just while they're listening and you're asking questions, if folks could address that survey, that would be appreciated.
Yeah, great. Thanks very much, Mark. And I'd like to reiterate that the answers to the surveys we find very helpful, particularly for developing our future presentations. So please take a few minutes or a moment and fill out that survey. And while some of you are doing it, I'll send another question to Craig. And this has to do with different kinds of composting systems and how they might, how their effectiveness might be for different odors, particularly for, well, questions about forced aeration systems. Might they perform better for certain feedstocks? And so I'd ask Craig, in addition to talking about forced aeration systems, maybe you could talk too about the differences in these various systems for how they perform.
Sure. As a rule of thumb, forced aeration systems do work better than windrow systems for odor management with potentially odorous feedstocks. And the reason being that in a windrow system, as materials degrade and break down, the pile volume shrinks. As the pile volume shrinks, free airspace is reduced. And that's so when you turn a windrow, you basically fluff it up again, but they settle back down. So you've got this constantly changing environment of free airspace. A forced aeration system, on the other hand, can operate either in positive mode, which is blowing air into a pile, and then you have a question of how are you managing what's coming off the top of your pile, which is why you would use a bio cover or a fabric cover. Or you could run in negative mode where you pull your air down through the pile and discharge it out through a pipe. But that creates its own issues because now you have a odorous airstream you have to manage with either a biofilter or a chemical scrubber. And you have a problem with the condensed water as well. So as a rule of thumb, forced aeration tends to be better for odorous materials than windrow, but it's not a silver bullet. You still have to manage the process properly and make sure you understand how you're going to manage that odorous air.
So it seems like the questions have slowed, and so we'll probably call it an afternoon here in Virginia. I'd like to remind everybody that this presentation, including the Q&A, will become available on a recording and possibly before Christmas, but more likely early in the new year. And I'd also like to remind you that you'll soon be receiving a notification or announcement for our next composting webinar, which will be January 19th. It'll be on health and safety. So if there are no more questions, I'd like to turn it back over to Mark and wish everybody happy holiday.
Yep, same here. Again, the recording should be available at the Learn event you probably used to get to this location, and feel free to share that with colleagues and friends who are not able to join us. Everyone have a great Christmas and happy holidays, and we'll see you after the new year. Bye-bye.
Bye-bye.